Okay, here is speedrun of the Excel Esports case. Almost there. How many points did the winner score in each battle? Well, how about a little pivot table action? But actually, before I do that, let's make it a table. So Control T, and I'm going to call that D for data. All right, so now I'm just going to do a pivot table on a new worksheet. And then for each battle, I just need to know not the sum of points, but maximum number of points. So I look at that on the battle. Oh no, I'm not looking up. I gotta look up on my pivot. So this on here, returning here. We'll call this piv because I'm going to need to go back to it to make more pivot tables, I bet. All right, points per minute for the specific participant in battle. So first of all, I'm going to do participant battle, right? So that is name and battle, just to help me look it up there. Then I'm going to do what? Minutes. I got to figure out how many minutes this actually is. So let's start with the harder one. So the mid of this, starting at 1, 2, 3, 4, 5, 2 times 1, right? That's the number of seconds, right? So that divided by 60 plus the number of minutes, right? Which is just the left two most characters of that times 1 is the number of minutes. And now I need points per minute is the points divided by the minutes. So then for XLOOKUP, participant name and battle on the participant battle, D points per minute is that, and it says round to the nearest integer. All right, who was ranked right after the person in the specific battle? Well, I mean, all right, so the ranking, what tiebreaker is name is the last tiebreaker, right? Then the lowest number of minutes, then the highest number of points by battle. And if I put everybody in order, I don't know, how many are there? 270 total. So I'm going to do a sequence 270, right? And just, paste that in here. And this is just, the rank order of everybody, right? So now I look up the participant and the battle on the participant battle, right? Returning on D rank order, right? That's going to be the person's position in the list. Then, add 1 to that. And then XLOOKUP again, that's on D rank order, returning D participant, right? Is all we're looking for this one. It's just the name. Should be good, right? Make sure I did all that sorting right. Yeah, it looks good so far. All right, so who is even or odd? Well, now I need the participants actually by battle. I can't just do them all here. So this is like going to be your real rank for the battle. So first person is 1. So if this equals this, then it's the same battle, right? So just this plus 1, otherwise 1. All right, so do that down to the bottom here. And now I've got everybody's rank by battle. And I can just paste values that right in my table. So this is like the real rank by battle rank, right? And this is your parity, right? Whether you're even or odd. Is even. So let's say what? If is even, then even, otherwise odd. And what? I'm summing some stuff. Average time for the entire battle for people with that parity. All right, so that is in my pivot. So I'm making a new pivot. And I'm going to refresh it for all the stuff that I added. And it's by battle and by parity. And I want to know the average of minutes is what I want to know. Average of minutes. And as usual, I don't want these grand totals getting in the way. So now I can just label lookup on here, right? I need to know battle 7 odd should be it, right? Oh, and now I got to change the format. All right, so put that over there. So now the integer part of that, and then the rest of that is equals this minus this. So the integer part of that, and it's always going to be 2 digits, and m colon and text, right? Because this I need to add the leading 0, right? So that times 60 as quote 0, 0, right? That'll make it in 0 zeros. If that'll add the leading 0 if I need it, and then tack on that s at the end. Those look right, I believe, and they are. Now it is map time. How many days to get to the next one of these green squares? So let us do a couple things, right? First of all, I need to determine, how many steps is it down this path, right? So I'm gonna use my maze solver to fix the path for us. So I'm just I could do this with a find and replace, but it's probably, I don't know, feels like a little faster to do it manually than with find and replace because I don't have to look up the color codes. All right, so 0 is there, and then we're going to go on a maze solver with no diagonal. Later, we're allowed to go diagonal, but on this, we can't cut the corners on this path. We got to go straight down this path, so no diagonal on the path, right? Because you're walking on the path without cutting the corners. All right, just make this a little bigger. And X to call so I can look up this stuff without having to use indirect. That's not what that's supposed to do at all. Oh, minus X to call, not minus X to call, just X to call. Thank you very much. Weird formatting in there. It doesn't really matter. Number, how about? I also need to know where these green cells are, right? Which should not be super difficult. I'll make another version of this, right? So this is for the green cells. I'm going to put just, the number 1 here to tag them, and then use fill color to put the ones there. So now if I X to call all of this, and then I just filter for the ones. Now I don't need to sort, just filter for the ones. Those are going to be my locations of the green cells. So if I take that and now I look up what is the position of each of these green cells on the path, right? How many steps along the path is it to each of these? All right, and then, so this is the address and this is the steps. And I do want to put these in order like that. And then starting from, right, so from F6, now I have to look up what number are we on the path, right? So how far are we on the path already? then how far is it to the next stop, right? So XLOOKUP, this on this, returning this, nothing if missing, but 1, the next value on the path. So equals this minus this is the number of steps to the next one of these. All right, so now we need to know if we're within a 10-day walk of a certain symbol. So I just put these symbols out here using x2call as usual. Then I just use my distance function, right? This, by default, it's using the chessboard or Chebyshev distance, which is exactly what this question is looking for. How many steps, like a king in a chessboard? So if, and let's say, this is less than or equal to 10, and the symbol is equal to this symbol locked, then 1, otherwise 0. All right, so we can just, sum these up. And that's the number of each symbol. All right, so now we're going to go on a walk. Got to avoid the snakes. Got to avoid the wall. All kinds of obstacles in our way, right? So I'm going to make another map for snakes. No, it's the snakes. All right, so I delete all this. And I use my neighbors. When I use my VBA formulas, I'm going to copy them over because I don't remember the arguments, but I can copy the signature over and use it. So neighbors count for snakes, right? So equals neighbors count. The array is the original map array here, right? That's the first part. The value is the snake. The distance is 1. Diagonal is allowed. And yes, your self counts. All right, so these 1s are the forbidden cells for the snake. Cannot touch, cannot go within 1 cell of the snake, which is what this is telling me. So now I'm ready to make my cell cost. So how much does it cost to go in each cell? Well, I mean, it costs 1 step to go in each cell, but some of them are impassable. So I got to mark those with a string. So if there's a snake there, well, let's use ifs. So if there's a snake there for snakes, so if there is a snake there, then we'll put an S because it's impassable for that reason. If there is a wall there, so if that equals the wall locked, then I'll put a W there for wall. Otherwise, it's a 1, right? Meaning that it will cost us 1 to get past it. All right, so there's my snakes, there's my walls. Everything else costs 1. That's my cell cost. And then finally, I just need the route cost, right? So that's my route cost lambda. It's going to use Dijkstra's Dijkstra-like algorithm to determine the fastest route starting from here going to here, right? So now is equal to route cost, the cost map, which we already created here, right? And the start reference, right, which we'll get from, doesn't matter which one start and end, actually, in this case. Diagonal is allowed for this, according to the instructions. So that's how much it takes to get to each one, and this is the lookup of the whole thing, so, that should be it, right? So now I just look up the final location on here, returning here. Takes it a minute. It's doing some Dijkstra algorithm action, testing all the paths for everything. Those look pretty plausible. Let's see if they're all right. Seeing lots of check marks, seeing 1,000 points so far. So everything's good so far. What country is the most common in this data set? Wow, that sounds like a job for my good friend Pivot Table. Country, and look, United States of America has 90. how many cacti and rattlesnakes. So just going back to this, right? Just do, you know, count if here locked is this. It's a tricky thing. You don't forget to lock when you copy that down. All right, 26. Maximum number of days you had to wait. Well, here on this table, right, it's just like this minus this is the number of days we had to wait, right? So what's the maximum? Looks like 35. Seventh highest overall points per minute in the data set. So overall points per minute means I need to add up everybody's points, add up everybody's minutes, and then divide, right? So if I copy this whole thing to give me another pivot table. No, I want the whole thing copied, please. Copy, paste. All right, so now I got a pivot table. So I want the names of participants. I want their total points, sum of minutes, and then P4 divided by Q4 is your points per minute. And then I want to rank this within everybody. I already got rid of the grand total, which is good. I wonder if there's some way to turn off grand totals. That would be nice. So this is this. I mean, I can already see number 7 here is right here. So it saves me writing the lookup because I see number 7. All right, so now we're going to go on. We're going to touch all of these green cells. Got to start at the last one, touch all the green cells. What's the shortest path? So to figure this out, I'm going to start with all of the green cells, which are here. All right, start a new sheet for bonus 5. So here are those. I'm going to start with, I want to make a transit table, right? So like how long does it take to get from each one to each one? Okay, and I'm going to do a 2. So if I start at this one and I end at this one, what happens, right? So let's say I'm doing a what if table. So I'm just going to put in 2, it could be any 2. Right, so now my route cost, my cell cost, route cost, I'll make a new route cost for B5. I think this will work. So this is B5 route cost. So this now is based not on the L7 center, but on the center in my B5 sheet. So move this up here so I can find it easier. So now the route cost is based on that route cost, right? Starting here, right, instead of there. And then the end doesn't really matter that much, but it is just X lookup this on here, returning here. I'm gonna save this in case I crash Excel with always a good idea before a two-way what if table. Make sure you're not going to crash save your document in case you crash Excel. So now it's got to calculate every single one of these. Hopefully it won't take too long. I mean, when I did this before, it did not take too long. So hopefully it's not going to take too long this time. I don't know. I didn't prepare anything to fill the time while we're running this. All right, there we go. So now I know how much it is to each node, from each node to each node. So I've got not a lambda, because I don't know if someone can do this with a lambda, I would love to see it. I don't think it would run in time in lambda with 9 nodes at least. With less node, with 3 or 4 nodes, you could do it as lambda, but with 9 nodes, it's a lot. It's a lot of possibilities. So we're going to use. So I created a Python traveling salesman function. Right, so this will determine the best route in the traveling salesman function here. unless there's something wrong with it. I shouldn't have anything wrong with it, right? This doesn't belong there. All right, so this is just going to find every possibility and find the shortest route. So if I copy this, right, and I say, so for Python, I want, this is the node data frame. And the start node here, right, is AO41. It says we have to start at AO41. That will make it much faster, because now it's just 9 factorial instead of 10 factorial possibilities. So, 300,000 instead of 3 million could be divided by 2, right? Because you don't have to test the same route in reverse, but I don't know. I don't think this Python formula is that smart. I think it tests everything. I think it tests every permutation, right? That's what it's doing here, is in itertools permutations, right? Finds every single every single node. It adds a start node if there is one. You don't have to have a start node. It could do all 10 if it wanted. I mean, it's already finished, so it's not, I don't know, it took about 20 seconds or so. All right, so the fastest route is 113. 113 steps. Stop the clock. Now you'll notice there's a red X here, and it still says I have 1170 points. That's because on the answer key, the answer is 116. But I feel like the answer is 113. If anyone here, if anyone listening to the sound of my voice can show me what I'm doing wrong here to get 113 and show me why the answer should be 116, I would love to see it. This is going from the green cells, right? So if you start here and you go, 10, 13, 20, 37, 71, like maybe if you're eyeballing it, like you don't think to go up here first and then to here, but that's actually the fastest route. Like I think that may be the difference, right? Is the case author just went directly to here and then back, tried to catch it this way, but that's not as fast. So I get 113. An alternative explanation is like these yellow cells, like the ones next to it, which is a little weird because it says in the instructions to start at AO41. So I assume you have to start at AO41 no matter what. If not, it would be 112 actually, right? If you're just visiting all 10 yellow cells. But I don't know. I don't think it's 116. I think it's 113. If anyone can prove me wrong, please do so. Thank you for watching.